Okay, remember last time in lesson 9, I said that sometimes we'll run into more complex equations that have more than one variable in them. Well, that's what lesson 10 is about. So now, instead of only having one variable where it's very simple, we put all the variables on one side and all the non-variables on the other, now we're actually going to pick a specific variable and move things around like a puzzle until we have the result we want. And that's called solving for a variable. And that's a term that you'll see in a lot of word problems. They'll say solve for length or solve for length in terms of width, or solve for x in terms of y. Those are the types of terminology you'll see that are indicating that you're going to try and take something with more than one variable and end up with only one variable on one side of your equation, which means you're giving what that variable equals. So let's look at this equation example that I have right here. 3x minus 2y equals 1. You'll notice that that is in standard form. Ax plus by equals c. And we could graph it in ax plus by equals c, but a lot of times it's easier to graph it in y equals mx plus b. So maybe I want to solve for y, which means that I'm going to have an equation that says y equals something. So let's take a look at this and say I'm going to solve for y first. So I have 3x minus 2y equals 1, and I need to get it as y equals something. So the first thing I'm going to do is take that 3x, and I'm going to take it to the other side, and it's going to become a subtraction. So I'm going to minus 2y equals 1 minus 3x. Am I done? I have the y all by itself. Or do I? I don't have y by itself because I've got this minus 2 sitting there. And I need it to just be y. I can't have it be minus 2y. It needs to just be y. So we're going to divide by minus 2, and divide by minus 2, and divide by minus 2. We're going to have y equals negative 1 over 2. Negative divided by a negative becomes a positive. 3 over 2x. That's not quite in y equals mx plus b, so I can write that as y equals 3 over 2x minus 1 over 2. We'll notice now that is in y equals mx plus b, and those are the same. So I just solved for y. Can I solve for x? Sure. I'm going to take that over here, and I'm going to have 3x minus 2y equals 1. And now I'm trying to get the x all by itself. So let's get rid of y. It needs to go to the other side. It's minus. It's going to become addition. So I'm going to have 3x equals 1 plus 2y. Am I done? No, the x is not by itself. It still has that 3 that's causing us some problems. Divide by 3 on both sides. So you divide everything by 3. I'm going to get x equals 1 over 3 plus 2 over 3y. So now I'm done. I've isolated for x. So you need to be very comfortable kind of switching back and forth between these different forms and viewing an equation as something that's very flexible. Each term is its own thing, and you can move it around and you can work with it and you can change the structure of that equation without changing the essential answer or solution to the equation, as long as you follow the rules. So let's practice. Let's look at these ones here. We're going to convert from standard form to slope-intercept form and back again. So the first one is in standard form, and I need to make it y equals mx plus b. Right? That. Let's make that look a little bit more like a y. Y equals mx plus b. Close brackets. That's what we're going for. So remember, I need to get the y by itself. So the first thing I'm going to do is take that 2x, move it across, and I'm going to get 8y equals minus 24 minus 2x. 8y, nope, not 8y. Divide by 8, divide by 8, divide by 8. I'm going to get y equals, what do you think, minus 24 divided by 8? That's a nice number. It's minus 3. 2 over 8 becomes 1/4 x. And then I'm just going to write this. I'm going to take these and I'm going to swap them so that it's mx plus b minus 1/4 x minus 3. So remember the sign, when you move them around on the same side of the equal sign, the sign stays the same and it goes with the terms. Just like when we collected like terms in Unit 1, when you move them around, you take the sign with them. So now we've got it into y equals mx plus b, easier to graph, depending on the numbers, sure. Let's look at the next one. Now we're going to try and get back to standard form. So we're trying to get back to ax plus by equals c. So I need to take the x over here. So that's a positive x. It's going to become negative x. So I can actually write this as negative 3x plus y equals minus 4. I'm done. It's that easy. It's much easier to convert from y equals mx plus b to standard form than to go the other way around. So as it says here, you should be comfortable changing back and forth between the two forms of a linear equation, as well as graphing both forms. You don't necessarily have to change standard form into y equals mx plus b in order to graph it. It doesn't have to be slope-intercept form, just sometimes depending on the numbers that's easier. But you need to be able to graph from standard form and from slope-intercept form, as well as convert between the two really quite comfortably. You should also be able to isolate for any variable as requested by a problem. So let's try a word problem that specifically targets this skill. So if the width of a rectangle is 4 centimeters less than the length, and the perimeter is 24 centimeters, what are the dimensions of the rectangle? So dimensions, when you're asked for dimensions, it wants to know length by width. It doesn't want you to do length by width equals. It doesn't want the area of the rectangle. It wants to know what is the length and what is the width. So that's the answer we're looking for. So I'm going to start by drawing a picture. So I have a rectangle like that. There's my rectangle. And it says the width is 4 centimeters less than the length. So if this is the length, what is an equation that represents the width? The width is 4 centimeters less than the length. So what I'm going to do is I'm solving for W in terms of L. That's what that's asking me to do. Solve for W in terms of L. So I need W equals. And the word problem gives us the clues. 4 centimeters less than the length. So that means the length minus 4 centimeters. It's not 4 minus the length. It's not 4 centimeters minus the length. It's the length minus 4. When it says 4 centimeters less than, that means you have to take the length and subtract the 4 centimeters from it. So sometimes the wording is a little bit strange, and you want to practice writing them out, because when you write them out, you write them backwards, basically, to what they're the way they're structured when they're writing. So length and width. Now, they told us that the perimeter is 24 centimeters. How can we find what the length and width are? The perimeter equation is 2W plus 2L. But I don't know W or L. But what I do know is W in terms of L. I solved for W. So let's take this and substitute it for W. So P equals 2 times the length minus 4 plus 2 times the length. Let's expand that and simplify it as well as we can. P equals 2L minus 8 plus 2L. P equals 4L minus 8. Am I any closer to having solved my problem? Yes, I know the perimeter. The perimeter is 24. So I'm going to say 24 equals 4L minus 8. Now can I solve for length? Yes, I'm going to solve for length. So 24 plus 8 equals 4L. 24 plus 8 is 32 equals 4L. If I divide both sides by 4, I'm going to get 8 equals L. So the first part of my problem says, therefore, the length is 8 centimeters. But is the question only asking for the length? No. The question is asking for the dimensions. That's the length and the width. So I really need to figure out the width. So I can substitute back into W. So if W equals L minus 4 and L equals 8, then W equals 8 minus 4, and W equals 4. So therefore, the width is 4 centimeters. And that's how you solve it. And you'll see questions like that on assessments. You'll see questions like that throughout the course where we're asking you to translate a statement, a word statement, into a mathematical equation and then use it to solve a problem. So the multi-step problems that are requiring you to really understand how to construct your equation and then how to manipulate it to find what you want.